Welcome to Algebra 2 Honors. This is Lesson 11. We are going to cover Section 1.6b, which deals with absolute value inequalities. Now, we talked about absolute value earlier in the year. Do you remember what absolute value is? Absolute value indicates its distance from zero, so it's always going to be a non-negative value. That is still going to hold true when we have inequalities. So let's think through what would be the case in this scenario. We have the absolute value of some number, x, that is less than 3. That means all the values of x have to be within 3 units of 0. So that means I could go all the way down to, but not include, -3, and go all the way up to, but not include, +3. So we have an intersection that goes from -3 to +3 on our number line. When we graph it, it looks something like this. What do you think would be the case for this one if we had the absolute value is greater than 5? I'll give you a moment to think about it and then we'll work it out. So if the absolute value is greater than 5, then that means all of my values have to be further away from 0 than 5 units, which means I have to have values that are less than -5 or greater than +5. When we graph it on a number line, it should look something like this. So we can't have values between -5 and +5. They have to be beyond that. Let me throw another one up here and see if you can do this one. We will have the absolute value of x is less than 6. Well, since it's less than 6, that means all my values have to be close to 0 because they've got to be less than 6 units away from 0. So once again, I'm going to have an intersection of values going from -6 to +6, not including those two values. When I graph it, it looks like this. Let's try this one. We have the absolute value of x is less than -3. Now for this one here, some of you just thought through some things and probably came up with a wrong answer. Others of you may have noticed something unique about this. The absolute value has to be less than a negative. If I take the absolute value of a negative, is it going to be less than a negative? No. The absolute value of any number has to be a non-negative value. It has to be 0 or greater. Therefore, I cannot have an absolute value that is less than a negative value. It's impossible. There are no absolute values that are less than a negative. There are no absolute values that are less than 0. And so there is no solution for this particular problem. Kudos to those of you who may have figured that one out. Let's try absolute value of x is greater than 3. So here I have to be further away from 0 than 3. So I'm going to have a disjunction or a union of sets. So -3 on down and +3 all the way up. So it's going to look like this when I graph it on the number line. And let's just try one more here before we get to some more complicated ones. Here I've got the absolute value of x is greater than -2. Now, many of you probably initially thought, whoa, we've got another negative here. But can I have an absolute value that's greater than a negative? You absolutely can. In fact, all absolute values are greater than a negative value. So for this particular set, it is all real numbers. So on our number line, we would have basically all values on that number line being included. So we would have arrows going in both directions. All points on the number line are going to be true for this particular problem. So as with absolute value equations, absolute value inequalities can be solved by breaking it into two inequalities. So remember when we talked about absolute value equations where they were equal, we broke the equation into two parts. The first part, we just dropped the absolute value sign. What do we do with the second equation? Do you remember? We dropped the absolute value sign and we changed the values of all the other parts on the other side of the equal sign. So what was negative became positive, what was positive became negative. We are going to do the exact same thing with inequalities with one very important distinction. Remember, when we're working with inequalities and we multiply or divide by a negative, what do we do with the sign? We've got to flip that sign around. So don't forget that when we're dealing with absolute value inequalities. Let's try one as an example, and I'll walk you through the process. Let's say I had the absolute value of 6y minus 5 is greater than 13. I'm going to break it into two different equations. The first equation, I'm just going to drop the absolute value sign. Everything else stays exactly the same. On the second equation, I'm going to drop the absolute value sign. I'm going to change the values on the right side of my inequality to negatives, the opposites, and I'm going to flip the sign around. You make sure you do all three parts of that. Drop the absolute value, flip the sign, and change all the signs on the other side of the equation. So the first equation, we just dropped the absolute value sign. We have 6y minus 5 is greater than 13 or equal to 13. On the second equation, though, remember I did all three parts. I dropped the absolute value sign, so it gives me 6y minus 5 on the left. I flipped my inequality around, so now instead of being greater than, it is less than or equal to. And I changed all the values on the other side. In this case, it was just the 13, so that became a negative 13. Now over here, I'm going to add 5 to both sides. On this one here, I'm going to add 5 to both sides. Then I'm going to divide both of these by 6. So y is greater than or equal to 3. And over here, I get y is less than or equal to a negative 8/6, which reduces down to negative 4/3. I do want you to reduce your fractions, although you don't have to make them mixed numbers. You may leave them. In fact, I encourage you to leave them as improper fractions. So now I'm going to graph those. So on my number line, I'm going to have a dot or a circle at the 3. I should have a dot at the 3. At the negative 4/3 or negative 1 1/3, should I have a dot or a circle? I should also have a dot. So I'm going to put a dot at both of those. Here I have to have values that are greater than the 3, so that's going to go to the right. Here I have to have values that are less than the negative 1 1/3, so I'm going to go to the left. All right, try some of these on your own. Here's the first one. We have the absolute value of 4x minus 7 is greater than 13. So once again, the first thing that I did is going to break it into two inequalities without the absolute value. So I dropped the absolute value on the first one, which gives me 4x minus 7 is greater than 13. On the second one, I'm going to drop the absolute value, flip the inequality sign around, and change all the signs on the right side of the equation. So that gives me 4x minus 7 is less than a negative 13. Now on both equations, I'm going to add 7 to both sides. So that gives me 4x is greater than 20 and 4x is less than negative 6. Dividing both equations on both sides by the value of 4, that gives me x is greater than 5 here, and that gives me x is less than negative 3/2 or negative 1.5. Again, reducing my fraction there. These are both not equal to, so I'm going to use circles at both my 5 and my negative 3/2 or negative 1.5. This is a disjunction. I can't have them combined, so that means I'm going to have my two lines going away from each other, and here is my final answer in a graphical form. Absolute value of 5x plus 2 is less than or equal to 17. So I'm going to break it into two parts. First one, I'm just going to drop my absolute value sign. The second one, I'm going to drop the absolute value sign, flip the sign, my inequality around, and the third piece is I'm going to change that 17 to a negative 17. Now I can subtract 2 from both sides of both equations. That gives me 5x is less than or equal to 15 on my left. On my right, it gives me 5x is greater than or equal to negative 19. Dividing both equations by 5, That gives me x is less than or equal to 3 and x is greater than or equal to negative 19/5 or negative 3 4/5. These can be equal, so I'm going to be using dots. They are going to be, can I have values that are less than 3 and greater than negative 19/5? Yes, I can simultaneously. So therefore, I'm going to have an intersection of points. So it's going to look like this. Once again, you want to check your answers. Don't just rely on your logic. Take just a few seconds and check your answers. If you did that with this one, you would have realized that, oh, it's the values in between these two amounts, therefore it's an intersection. So those are going to be my answers. These guys over here are not. Just for a quick run through, let's try 0. If I plug in a 0 here, I get 2. The absolute value of 2 is 2. Is 2 less than 17? Yes, it is. So it works here in the middle. If I try a value of something like negative 4, if I try negative 4, 5 times negative 4 is negative 20. Negative 20 plus 2 is negative 18. Absolute value of negative 18 is a positive 18. Is 18 less than 17? No. So this part does not work. Same thing over here. If I use a positive 4, I get 20 plus 2, which is 22. Absolute value is 22. Is 22 less than 17? No, it is not. So this piece over here would not work either. So I encourage you, once again, check all of your answers. You don't have to write your check down. You can do most of the time. You can do it mentally. I encourage you to do so. It's better to get correct answers. Now let's see about creating an inequality based on information given to us. Let's say Audrey is looking for an apartment. The average monthly rent is $1,400, but it could vary by as much as $225. So before we get started, let's think through. The average is $1,400, but it could be $225 more than that or $225 less than that. That is what this is saying. So it could be as much as $1,625 or as little as $1,175. Now, how would I write that as an inequality? This first time we do it, it may seem a little bit weird, but as you work more and more of them out, you get more and more comfortable with them. What I'm going to do is I'm going to take that average of the $1,400 minus the actual price of the apartment. And I'm going to set that to some inequality of 225. Now, when we do that, we got to think about what our inequality would be. So let's just start off by saying I've got the absolute value of $1,400 minus the price of the apartment. I need some sort of sign here, inequality. It could also be equal, so I went ahead and put my line for underneath it. And then my price of $225 that it varies by. So it's got to be within that range. So let's just say P were $1,200. Okay, so if the price of the apartment was $1,200, which is within the $225 value of the $1,400, so that would be $1,200. $1,400 minus $1,200 would give me $200. $200 is less than the $225. Let's try the other side. Let's say it were $1,600, which is greater than the $1,400, right? So we have $1,400 minus the $1,600. That gives me negative $200. But when I take the absolute value of it, I get $200, which is still less than the $225. So you create your inequality doing that. There is going to be some trial and error to it, but it will help you as you think through the process. Once again, we are wanting you to start thinking things through, not necessarily always giving you the exact way of finding it, but rather muddling through and doing a little bit of trial and error, trying to figure out what works and what doesn't. But I did want to give you at least a little pointer. You take the average price there, subtract whatever the actual price is, and set that as some inequality to your variation of the price. So here, I already did this, but we can work each of these out individually. If I Here I just took out the absolute value. Here I took out the absolute value, flipped the sign around, and made the 225 a negative value. If we solve both of them, we end up getting the price of either 1175 or 1625, which is what we came up at the very beginning when we were just talking it through. If I add 225 or I subtract 225. But this is kind of our double check to make sure that our inequality portion is actually correct. Try this one on your own. Ethan is pricing colleges and finds that the average cost is $37,250 per year, but it can vary by as much as $14,000. Take a moment, see what you come up with. Remember, check your answer before you just call it quits. Okay, so I'm going to take the actual average price, that $37,250. I'm going to subtract the real price, the P value, or whatever value you may have used for your variable. And it's going to be equal to some inequality of $14,000. It's got to be within that $14,000. So we are going to be using a less than or equal to sign. If I check my answer, again, the first equation, I'm just going to drop my absolute value. The second one, drop the absolute value, flip the sign around, and change the value of the last piece there. Subtracting the 37,250 from both sides, then dividing both sides by a -1 or multiplying both sides by a -1. Red flag, ding, 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 ding. We're multiplying by a negative in an inequality, therefore flip the sign around. So T is going to be greater than or equal to 23,250, or it's going to be less than 51,250. So that tells me that our inequality is correct. If you had this sign switched around, as you do your check, you should realize it didn't work out. I ended up getting, instead of an intersection, I got a union of sets. That means my sign is wrong. Flip that sucker around. Go back and just do a quick double check. You don't even have to erase everything. You just have to erase the sign and make sure it all works out, and it should be good. So that is what we learned today. We talked about absolute value inequalities. Make sure you keep in mind when you're working these out how to solve inequalities as well as how to solve absolute values. Combine those two concepts together and you should have no problem. Where you're probably going to have the most difficulty are on these right here. Initially, it's just going to be some trial and error, but again, as you work more and more of them out, you'll get faster and faster and you'll have more and more success.